Hello there. Today we're going to be taking a look at repairing this Sharp PC-1251 that I was so graciously sent. However, it has one minor issue. The LCD is completely roasted. That's not a polarization issue that you're seeing here. It's just black. Now, I haven't tried putting power to this thing yet, and we will do that later and see if it has any other issues. But I can tell you that this is not going to be a workable LCD. Now, thankfully, as we previously explored on this channel, this is no longer the death sentence that it used to be, because there are now reproduction LCDs available for these machines, thanks to Robert over on Tindy. And I will have this linked down below if you have one of these that needs repaired. So today we are going to be installing a brand spanking new LCD in this. And yeah, that's the color that it should be, not black. All right, now, like I mentioned, this is very similar to the TRS-80 pocket computer that I last did this with. However, this machine has a whole lot more going on, though this is just this part that is what we will be working on, at least theoretically. This has a lot more hardware in it, the printer, the cassette drive, probably a serial interface somewhere. No, maybe not, but there's a lot of cool stuff here that I'm hoping we can check out, and we are going to try to utilize this as the power supply. I do need to check if there are batteries in here. I don't think I did look for that when I unpacked all of the calculators that I was sent here, but let's see what we're in for with this and open this up, because I don't know exactly what this is going to look like in here, but I do know we're going to have multiple zebra strips to contend with to get this installed. All right, hopefully we're not in for a rude battery surprise here. Okay, also I should pay attention to whether or not these are bespoke lengths for each side. No, they do not appear to be. Okay, so let's see, do we have, yeah, that's the typical construction. It's almost like hinged onto the top here. And there is the battery compartment and empty. Sweet. So we're all good there. That's refreshing. Okay, so after you get those out, you have something delightful to contend with here. Apparently, this just comes off of the button array. Yay! Oh, wow, you can really see how screwed the LCD is there. We'll look at that in a moment. Hold on, I need to rebuild the keyboard here really quick, and then I'm going to put this back, and then I'm going to flip it over, and then I'm going to take a picture. Let's go back to the back side here and figure out what we can or can't. Oh gosh, there's a cable. That connects to the piezo, connected right there. And I think there's a little zebra strip. Yeah, oh, that's horrible. Why would you guys do that? Oh my gosh. So I know we're going to encounter zebra strips for the ITO pads on this, which I can kind of make visible there, but I wasn't expecting it for board interconnects. Jeez. So, all right. I think I want to desolder those two wires though, so it's time for more documentation photos. Oh, at least it's good solder. All right, now I'm gonna put this upside down because there's that zebra strip there, like I mentioned, and actually, you know what? I'm gonna float this on the plastic tub again here. That way it doesn't touch anything or collect dust on the zebra strip. What on earth is that? I think they needed to just run a couple more wires in their traces, and they're like, we give up. Sure. Good job, Sharp. Yeah, so these kind of suck to replace, I am remembering. So we have these metal tabs that you can see poking through, and more particularly the ones there that wrap around the PCB and go to this metal shroud that's holding the LCD down. If I remember correctly, that is what applies the force to squish the glass to the zebra strip. I think that's part of the power switch there. So we will probably clean that with some alcohol and a melamine sponge, I think. But yeah, we're gonna have to bend these tabs up that are all around. I'm hoping there isn't one. Oh, well, that's delightful. Thankfully, it's not bent, but that is a tab under the volume wheel or contrast wheel. That's contrast, not volume. Thankfully, that's not bent though. I don't think we have to touch that. That's just used for alignment. So you see how it's kind of like purple smoky kind of thing going on there? So that's, I believe, the polarization layer glue kind of causing distortions. It might be possible to re-glue the polarization layer. I'm not 100% sure, but I don't think it's likely because I feel like people will be doing that. You will see something somewhat similar on like ThinkPads, and it is possible to repair those LCDs, but I don't think this one comes apart as easily. This might be a worthwhile experiment to try it with, though. I will keep this panel and see at some point in the future, perhaps. All right, anyway, though, enough yakking. Let's start trying to bend these up, which I remember sucks a whole lot because they are extremely flush. So I do think my best bet is going to be getting the ones along the top row off and then bending out the panel to hopefully bend these up a little bit to make it easier. Let me show you how much force it's putting on this. Okay, just give you a reference here. Look at how much the PCB is bowing on there, okay? Like look at that. Okay, these are clamped down tight. This is not easy to remove. They really did not want this coming off. So it's gonna not be easy to get a tool underneath of this to bend it down. They really bent the snot out of that. I'm going to try the spooky solution. I don't think this is gonna work either though. Oh, wait. Okay. Ooh, that worked super well. I think the benefit that had was being able to slide along and kind of either cut the circuit board or the metal. I'm not sure. Highly recommend adding some super fine needle nose pliers like this to your tool set, by the way. They are really helpful. Okay, so now that I have one side released, here's what I'm gonna do. I'm gonna bend this out, if I can get it to release without destroying the zebra strip, which is easier said than done. Wow, it is really sticking to the PCB, geez. Final stretch. You can do it. Yes. Boom. Okay. I'm gonna bend this down, which will bend the tabs on the bottom side up. Okay, I'm gonna go with that. Now, they're all bent. I can just grab them, bend them straight up, or straight up. Straight up works as well. Beautiful, there we go. And that is the LCD removed. Okay, I'm going to call out that the digits go towards the bottom, but also I can't even see the digits on this. So this is a circular polarizer, all right? I'm gonna put this on the lens. Okay, well, that's cool. Okay, I might have one hint of the orientation on that. So with a very careful alignment of the CPL and that light behind it, we can actually see the contact pads that will connect to the zebra strip there. And we can see the gap right there. So that should be our top side. So we should be able to look at that to know for sure whether or not we have it correct. So out of curiosity, Yeah, we can actually see that there too. This one's a little easier to see, even. So while we're in this close, let me explain how these zebra strips work. So you see those little black dots in there? So those are actually columns that go all the way through a piece of silicone, and they provide vertical conductivity. So these are conductive in this direction, up and down, but they're not conductive next to each other. So you're able to lay this silicone strip down on top of the PCB here, and then only the pads that are meant to connect to the little contacts here do, because they connect vertically like that. And you can see that they'll get about two or three individual little tubes to connect to each pad, which is just enough to make the LCD work. They're not super high current devices. So that's how you connect glass to a circuit board. You use the Z-conductive zebra strip like this. So that's what's going to be transplanted here as part of this process. We have to move this over. You can also see this is the part that was sticking where there are no contact pads, and it just had one really big flat patch that contacted the PCB. That's why it's stuck so much there. So I'm trying to be extremely careful to not touch that side of the glass. And all right, so what we need to do next here, and then I immediately touch the glass. Okay, you know what? This is one of those rare times where I'm going to clean this and I'm going to put on gloves. So the finger oils getting in between the zebra strip and the LCD are a substantial problem. So I want to make sure that that does not happen. So I'm going to put the gloves on, and then I'm going to use some light alcohol solvent on there to clean that. And then I will be sure not to touch it again. Actually, while we're here, I might as well clean off the power switch contact as well. I immediately regret cleaning that first because it was super disgusting, and now that cotton swab end is ruined, but whatever. I don't believe I have touched the circuit board. I won't regret it, at least I think. So I think what we'll do, I'm going to peel the zebra strips out. And then if I have to heat this up, it won't be as big of a risk. I really, really don't want to stretch them. Now it will be better to match these up to the correct sides. It will be paramount that I do not let this touch the workbench. So this is the top side, which I can see is over there. Okay, so there's one down. Let's break the other one free. Okay, towards my thumb is the inside. Okay. Now, I'm going to put this off to the side, and I'm going to loosely cover it with this so dust and stuff doesn't get on it while we extract this, because this is going to suck. All right. So step one, I'm going to make it nice and flammable, and then we'll probably end up heating it up. So there's a glue underneath of this that is holding that panel down in place, and we're going to have to remove it. Man, they really did a good job of forming this piece of metal. This is a fully stamped and rounded corner. It's not just folded over. So there's no gap to try and get underneath. I think the only way I can press directly on the LCD is right here. And if I try and do that with this, I am going to crack it 100%. I think this is where we turn on the 3D printer and pop this bad boy on the bed. Ow! Aha! Whew. Boom. There we are. One old LCD. Well, that was a lot of excitement. Finally got it off by setting the printer bed to 100 degrees Celsius and then just really mashing on the old panel. I think at some point I managed to get alcohol inside of the liquid crystal because it's really like weirdly grainy and splotchy looking in there now, and it was not like that before. So I think the solvent managed to somehow leak between the LCD layers, which is really cool if you're working on something where you're actually trying to repair the LCD. But anyway, now we're gonna put this one in. The top has the gap in the ITO layer, and I can see that there. So this one goes right here, kind of, sort of get in there, please. I'm gonna push the zebra strip kind of further in here. Hoping it gets slightly more even pressure when I go to bend those tabs down rather than just being pressed up against the edge. I can see I need to straighten this one out. This probably got bent while I was applying the pressure to pop the LCD out. This one is super bad too, yeah, okay. Make sure these are nice and straight. Okay. And that's the correct orientation. Okay. So, one of the really fun things about this is that there's no real way of knowing if it's gonna work without just putting it all back together. And these zebra strips can be kind of finicky for making really good contact. So we might be in for this for a little bit here at this point. So from here, for the video, I'm going to just keep working on massaging this in place and getting these clamped down until it's as good as I can make it. So we'll see how that goes. I will record clamping this all down once, but yeah, I'm not kidding. There's a very, very real chance that we will be taking it apart and trying to adjust the zebra strips multiple times here because they really suck. All right, I think we should start folding down the tabs. I'm gonna go inside out. Joey, oh no! Oh, God! You see that? It's not a crack. There's a protective layer on there I forgot to remove. It could be worse. It's just, like I said, gonna be like 12 different times we're gonna be taking this off and on and putting it back together. And now begins the part where I slowly contaminate the zebra strips because I start getting distracted because I'm doing too much stuff. Now we hope that the glass just comes out nice and easy. Well, the good news is there's a chance that the glass, yeah, will separate from the peel. Like it just did. Peeling the film just caused enough of a static charge that it caused a digit to show. Did you guys see that? And then zebra strip is probably screwed because, like, that's the dumbest possible place for one. Here we go. These are just CR2032s, right? Maybe we try this separate from the dock. So upside down here, and then right side up there. And then the switch is currently in the on position, so I'm going to slide that to off. Pop this in. And moment of truth. It's busy. It's okay, I can wait. I wasn't in any kind of hurry, I guess. Take that off. Busy is no longer on. Put that back on. Busy is active. All right. Brake. No. If I put it on off, release the battery door. Oh, wait. That did something. Ah, okay. Hold on. Let's go to program. Oh my gosh, did we nail it first try? No way. Nuh-uh. Holy moly. I think that might be good. That went so much smoother than the TRS-81. Oh my gosh. I mean, yeah, it still sucked to install the LCD, but like it actually worked. I mean, I guess we can put the back on now. Off. Oh yeah, I'm excited. Okay, well, we have the first part of victory done. Now the question is, what happens with this? Because I don't know. However, before we pop that in there and plug it in, which by the way, this has a DC power socket, and in theory, I believe this is the power supply for it, but it says low battery right there. There's an LED indicator, so I'm wondering if perhaps there are batteries in this that I did not think to remove. So let's just have a look-see real quick and find out if there could be problems with this thing. One moment. CE125. Okay, this is this thing. Instruction manual. Power supply, microcassette, blah, blah. Your printer recorder is powered by a rechargeable NiCad battery. Uh-oh. Yeah, we got to get this thing open. Okay, well, there's the battery. Looks like it's just the AA NiCad cell, so this might not be too bad. Ah, haha. Nick of time. So it just barely started to corrode there. And it has not, I don't believe it's gone up the wire yet. So where does this go? To here? Yeah. So that's the other end of the wire. It has not started to corrode. Negative terminal looks fine. So yeah. Oh man, that was lucky. So we're gonna see if it'll be cool with not having that. Because I don't know. But we're just gonna yoink that sucker out. There we go. Yoink. From looking over the schematics of this thing, the input for the power supply comes from here, jumps across this diode, which in the schematic is not easy to see. I'm looking at that on another monitor here, but I'm pretty sure this is our voltage regulation here. So this is a Zener diode that should bleed off any excess voltage, which is a weird way of doing it, but it was kind of common in older devices like this. So the Pioneer SX780 that I restored had a blown Zener diode that set the voltage, I believe that went into one of the amplifier packs on that. I don't remember exactly, you know, got to remember that was like 2019 or something, a long time ago. But they're not the most robust devices ever. So there is a possibility that if I plug a power supply in that is higher voltage than this is ready to bleed off, it might not have a good time. So there's a chance that we blow that up, which I'm not crazy about because that might do some bad things, but we're gonna go ahead and try a Sega Genesis power supply because if that works, that makes for a very easily sourceable replacement for this thing. And yeah, this particular one has seen some better days, but it's fine. It'll make it easy to replace a power supply for this. So let's see what happens when we plug that power supply in. I'm not 100% sure. I think we can turn printer on or off, but we'll just go ahead and plug it in for now. So this is on my switchable outlet. So I'm just going to take a step back here as I apply power. So here we go. It did not explode, which is a good sign. So if I turn on power to the printer, nothing really happened. Okay. I want to make sure we have roughly 4.8, or probably I think it's going to be 6.2 volts going to the battery terminals there when power is applied. So let's go ahead and do this. Here's where foot pedal becomes super awesome because I can apply power with it's already applying power and it's not even on. There's just that much charge in there, I guess. Okay, well, I'm going to turn power on. So we can see 5.7, 6.2 volts there. So that's about where it should top out. Okay, that's good. And then I can turn power off. Okay, the foot pedal's awesome. So I think that's okay. And I can probably close this up and try docking the computer to it. All right. So the computer docks like that. We apply power here and then run. Now, I have no idea what we can or can't do. Low battery flashed a little bit there, but then stopped. So I'm going to go to program, and usually you can do print and then space high, and then that would, or not, 10 print space string high string enter run enter. Okay, so that worked. We printed to the screen. Okay, so now I'm going to go back to program and I'm going to do lprint, and we'll see if this syntax I need to make this in a number or on a line number. I'm going to change my print command to lprint and see if it will print to the printer with that. So high, enter, run, and, okay. Printer operations, okay. Connect it to the computer, turn the power switch on, and then the printer switch, press the CL key, okay. Print out formulas and manual calculation, symbol P. For printing, use of list and print statements, refer to the PC instruction manual. Some results in the manual calculations, display symbol P on the computer. Shift PNP. So clear, there we go. Clear has been pressed. 10 plus 2 equals, apparently that's not what you do. Enter 12, okay. And then shift NP. Now we see P over there. 10 plus 2. Okay. So that's something. We got it to print. 10. It didn't complain about the syntax of lprint. I'm going to try lprint again. Lprint high. Enter. Go back to run. I really hate using this to switch programming modes because I feel like I'm just going to turn it off. Run. Ah! Wait, what? That was not... Okay. Run. There we go. It printed high. Finally. lprint. Tech. Wait, hold on. Can we do... I don't think we can do lowercase. Tangents. Can I just hit just R? Low battery? I don't like that. And then busy. I don't like that. Error. Okay. Run. Why did that work? R might be an actual function, so maybe that's it. But there we go. The printer is working fantastically, so that's pretty sweet. So, that is operating. Now the question is, can we store a program? But in order to do that, let me just take a quick trip over to Radio Shack. All right, I'm back from Radio Shack, and I have some brand new realistic micro cassettes. So, I'm hoping these are going to be compatible with this so that we can actually try to write and save a program on this thing. So we'll probably just go ahead and save that because this is going to be complicated enough. There we go. So that is one tiny little cassette. Now, the head for this is on the bottom side. So we're going to feed this in this way. Oh my gosh, look at it. It's beautiful. Okay, here's the discrete manual. C save contents of program, reserve memory on tape. C load compares program on tape with contents in memory. Merge combines it with prints the contents of variables on tape. Retrieves. Interesting. Okay, so the way this will work, so it's C save and C load. That's easy enough. So we should rewind, and we're at the end of the tape. Perfect. So we have in memory list our, okay, let's go back to program mode. We have in memory the lprint tech tangents program. So I'm going to go ahead and hit play and record, which actually record will hold down play for me. I'm going to go to run here. And then I'm going to note that that's not actually spinning. Belts! All right, so we may be out of luck on the cassette. I didn't think to look for a belt in there. Oh my gosh, it's gonna be so tiny. I just kind of assumed it would be direct drive. Darn. But hey, we got the computer working. The display is perfect. We have seen zero issues with that at all, which is absolutely fantastic. And being able to do list, I guess, in program mode, it printed, that's a good show, printer. And this time I'll put the I in there. We can see even on the last character, which we couldn't see before, previously, that is working. So other than the cassette belt, which I did not think about beforehand, we're actually doing pretty good here. So I would say that was a complete success. Well, there is the Sharp PC-1251 with its fresh, brand new display working. And to anyone who has one of these, you probably want to go ahead and remove that battery that's going to be leaking. And at least it looks like it's easy enough to get a replacement power supply going for this, because that's, again, just a Sega Genesis power supply. So that's a maybe easy way to get one of these up and running. But yeah, definitely a cool little thing. I'm going to have to find a belt for this, which means I'm going to have to tear it apart again, try and measure the belt size, and then order a replacement belt for that. I did not think that was going to need belts. I thought that would be direct drive, but I should have expected it. Oh well. But that is going to be it for now. If you enjoyed this look at repairing and restoring this Sharp PC-1251, you may want to subscribe and be notified when I release more videos. If you want to help support the channel, you can find me on Patreon. But for now, that's it, and I will see you next time.